Good morning, friends. Let's conclude our discussion about accumulators in this final video, in which we will be discussing about our own accumulators by subclassing accumulator V2. So in the previous videos, we have already covered the native accumulators like long and double, and also the string accumulators. So if we want to create our own accumulators, which is our own custom object, so in that case, we have to subclass this accumulator V2 class. This accumulator V2 class, this is here in the in the Spark API. And once we extend this accumulator V2 class, we have to pass the in and out parameters, which should be also serializable. And after that, we have to just override all these methods which are listed here, because these are marked as abstract value members like add, copy, is zero, etc. The similar thing we did in the previous video when we tried to create a string accumulator. So let's discuss the use case first, that what we are trying to build. Suppose I am working on an OMS system which has got a lot of trades throughout the day. It can be like thousands or millions of trades to be done almost every day. It's a very high trading revenue system. And I want to create a stock position accumulator. So for example, in this naive example here, in this test case, suppose I've got 6 trades. In these 6 trades, we have got 3 trades for Apple, 2 trades for Meta and Tesla, and 1 for Tesla. So we want to create a stock position accumulator for each of the securities IDs. For example, in these 6 trades, I can create 3 stock accumulators, 1 for Apple, 1 for Meta, and 1 for Tesla. And what we are trying to do in this stock position accumulator is that we are trying to calculate the overriding position and the profit. So for example, we have got 3 trades here. There are 2 buy orders for Apple, and the third is for the trades for the sell. So if I want to calculate the position and the profit across all the 6 trades for only Apple stock. So for the trade first, if you can see that the executed price is 50 and quantity is 100. So if the notional would be 50 multiplied by 100, which is 5,000. And the position is that how many stocks that I have right now once this trade happens, because this is buy. So the position would be 100. For if it's like sell, the position will be subtracted. So this is my like accumulated position as of trade 1, which is 100, because the quantity is 100, and the profit would be minus 5,000, which is the notional, and it's negative because we are like taking the cash flow out to buy this trade, to buy the stock of 100 for Apple. Similarly for trade 3, if you look this trade 3, so here is again the side is buy, which is we are again buying it. And the notional for this would be 51 multiplied by 100, which is 5100. And the position now, this is what we are going to accumulate. The position is now 100 plus 100, which is 200. Okay, so this is the position, means that this currently we have got 200 stocks we have bought for Apple. And the profit would be, again, because we are taking the cash flow out, we are buying it, we are taking the money out of our account. So that's why it would be again subtracted. The notional would be subtracted, and our new, the profit would be minus 10,100. And finally, in the trade 4, this one, again we have got this is a sell, because now we are like unwinding our position. So and this is for price 52 and 200. So again, if we do all this mathematics, the same, the notional would be 10,400, because the position now we are actually selling whatever we have bought, all 200. So that's why the position right now is 0 after this trade 4 for Apple. And the profit would be for 300, because right now we are actually selling it at 52 price. So after doing all these calculations, this is our new profit is 300. So this is what we want to build. We want to build a stock position accumulator for each of the securities we are interested in, and calculate all this position and profit on the fly using this accumulator logic. Now in this unit test, I am only doing all these calculations for Apple stock. As you can see that we can create this stock position accumulator using the security ID, which is Apple. Now let's go to this class. So this is what we discussed, that this is how we actually create our custom accumulator, in which we have to extend this accumulator V2, which was there in the API. So let's go back here again. So this is what we are talking about, V2. And we have to, and the in and out parameters which I'm using is stock position. As mentioned, this stock position, this would be working as our accumulator class for, say, Apple, once we create this. object. Let's go to stock position first. So stock position is a simple which implements serializable. This is very important. Otherwise, it will not work in the accumulator class. And only has got this security ID. In our case, it's Apple. And the list of trades that we have to filter on. I mean, all the trades which we have only got for Apples. So in our test case, I mean, when we have got 6 trades, only 3 of the trades were belonging to Apple. So this would all come into the stock position for Apple object for in the list of trades. And here we are actually doing all the calculations for profit and position. As you can see that these are just the getters and setters methods. And when we add trades, whenever the list of trades are being passed, we only filter the trades which are for this particular security. Say for example, Apple, and then collect it. So this trades will be only containing all the trades only for this security ID for which this stock of position object is created. And then we have got simple equals and hash code. So get trades, just one thing I want to highlight is that whenever we are trying to get the copy of the original list of trades, we always use immutable list.copy of, so that our original list of trades is like not corrupted by the client class, whichever is trying to get it. So this is about stock position, and then let's talk about trade class. So trade class is again it's implemented serializable, and the list of trades that we saw in our unit test case, those all is like new trade. This is what I'm talking about. So this has got security ID, the time of the execution, price and quantity when it was the last price or the last quantity, and the side. And it just has got relevant getters and setter methods along with equals, hash code, and toString. And the final thing is about side, which is enum, buy, sell, and short sell. So this is our all class structure. And let's go back to our main stock position accumulator. As mentioned that I have all overridden all those abstract methods which are there in this, so that our like class is ready to be used. So we have got is zero method where we are just counting it to zero. Copying is again like very much similar to how we do a clone of an object. So we just pass these two parameters, count and stock position accumulator, when we are doing the copy. This is what we are doing. We are creating a new object from the security ID, and then passing these two member fields parameters and set it here and then return it. For resetting, is again quite clear that this resetting means that we just put the count to zero, and whatever the position that we accumulated, we again create a new one of that, which means that all those like profits and positions will be marked as zero, because we are creating this new object out of it. Now this is the most important part which we're doing the accumulation. So whenever we pass this stock position, because this is our in and out parameter for accumulator V2, so this is what we are doing here. We get all the trades for that particular stock positions, and if the trades are not empty, we get the security ID in the accumulator, and then we again filter it out for all the trades which are only meant for this particular security, which is in our case is Apple. And once we have got all these filtered trades, this is what exactly we are doing. As we saw in the mathematics calculations, we get the last quantity, last trade from the trade, get the notional, then we set the position and the profit from that by taking this get position and get profit. And after that, we do this calculations based on whether it's a buy or a sell. So we have got buy, sell, and short sell. So only for buy, what we are doing is that we are increasing the position by the quantity that we get. So again, let's go back here. It's what we are doing here is a buy. So we get this notional, and the quantity is just added in the position. Quantity is just added here in the position. 100 quantity, we are adding it here. And for the profit, because whatever the profit was there before, if it's a buy order, the current date is buy, we had to subtract the notional out of it. So this is what we are doing here. So the profit is profit minus notional. Similarly, for the opposite side, if it's sell or short sell, in this case, we are just setting the position to, because we are selling it out, unwinding our position. So we have to decrease this position with the last quantity and set the profit with by adding the whatever the profit was there before with the notional. So this is our main method, which is doing all this calculation. And then finally, we have got merge. Merge is again similar to, it's quite simple that whatever the other accumulator that we are passing, we have to add the count of it, and also add all those positions that we have accumulated in the other object here as an argument. For example, if we have the total positions, we have to set the position by adding it, and the total profit is also added. And inside the logic, we have already learned that how whenever we try to add anything, it would be already taking care of all those calculations based on the side, which is buy and sell. And then finally, the getters for value and the count is also provided here, because this is also value is also like something which is only can be read at the driver side. So this is all about our class structure. Now let's actually go through the unit test case again, and let's see whether it's working as expected. So in our unit test, we create a Spark context as before. We have the security ID for which we are trying to calculate our stock position accumulator and calculate this profits and positions based on the trades that we are receiving throughout the day. So we create this accumulator class by passing this constructor parameter, and then we register it with a particular name set as Apple position ACC like this. And so this is what we can assert, that by using this name, we can actually get the exact name that we have set it here while we are registering it with the Spark context. Now we have got set of 6 trades. 3 of them for Apple, others are for other securities, which we are not monitoring right now, but we can create it later on. I mean, if needed. So for Apple, I mean, we already did the calculations that after trade 4, what should be the position should be 0 and the profit should be 300. So what I've done is that I just try to mimic it, because like the first bunch of trades that we get at time from 1000 to 3000, just like a long variable, we got like 2 trades, set of trades, 3 each, and then we create the stock position out of that for the same security ID for Apple, and then we add trades. So when we add trades here, it would be filtering in the stock position for Apple. It will be only taking first and third trades. And here, once we add the trades again for the second time, it would be only taking the trade for stock position for Apple. And then we finally get the Apple stock positions by just using the list of both of them. And then finally, we are going to parallelize it. Parallelize means that we are going to create an RDD out of that. So once we create the RDD out of that, we are simply calling this add method. For each, just you look at this lambda, and this is the method reference here by calling this add. In the add, as we have seen in the logic, that we are going to calculate all the profits and the position based on the side of the order or side of the trade. Okay. So again, is 0 means that, I mean, of course, we have got some like 2 positions there. So it would be, the count would be 2. And after that, I think the most important part is that about this profit and position. So let's look. This all we have the all assertions before that we have already checked in our previous long accumulators and double accumulators and string accumulators examples, unit test cases. So I'll not go through it again. Just want to just last point is that if the value can be called only at the driver side. So this is what we are asserting it here. But the most important part is that this one, these 4 assertions. One is the security ID should be always Apple, because we have only created the stock position accumulator for Apple. The trade size should be 3, because as we learned that there are 3 trades for Apple, 1, 3, and 4. And the position should be 0, and the profit is 300. This is what all the calculations that we did based on the trades and the side. After that, so this is the main assertion that should be working as our expectations, as our theory. And finally, it should be once we call the reset on it, the accumulator should be resetted to 0. So this is all about our stock position accumulator. And as mentioned, that we can also create similar type of position accumulator for other symbols that we are interested in, for example, Meta or Tesla. And this is very handy, because I've seen that if there are thousands of trades, and we are trying to do all these positions and accumulations across, if we have using Apache Spark as our big data solution. In that case, this accumulator works very, very nicely and very fast. So let's run this test case to assert that everything is correct and as expected. So as expected, our test case worked well and everything is good. So all our sessions here, this were all good. And the position and the profit after the 3 trades of Apple, they were all good. So it keeps on doing it, I mean, for throughout the day, if you're trying to do the accumulation of position and profit. We can extend this topic, the same concept for calculating the risks, P&L values, etc., where we can just create an accumulator, and based on the trades, we can calculate the risks that are associated with it. Because for calculations of, for example, for P&L, PV, and cash, and also that also involves the logic of calculating all those the present values, quantity, and notionals. So yeah, this the same concept of the stock position accumulator can be extended to other concepts where it requires a similar type of additions and accumulations. So guys, this was all about chapter 16, in which we have covered all those things that we have discussed: the closures and the shared variables, broadcast variables, and accumulators. And in the next chapter, we are only like 3 chapters away before we conclude our Spark RDD tutorial and then start our Spark sequel. In the next videos, I will start with chapter 17, which is Spark RDD submitting applications. So see you all in the next video.